Now taking the stage will be Mr. Terry Lindeman. He'll deliver the keynote on makerspaces, what they are, how they function, and what successful models look like in schools. He's the Makerspace coordinator at Canadian International School. So,
my name is Terry Lindeman. I've been doing education for about 30 years. I've got a master's in educational technology. I got my master's in wireless, was just getting started. Today I want to share with you some things regarding what we do in our makerspace and how to set up makerspaces. Myself and Ms. Pavana, we are the coordinators at CIS International School, and we do the makerspaces. Great. I start with this right now. I want to show you something. Just now pay attention to the numbers, and then I'll tell you what we're doing here. Oops. It worked earlier. Okay, that was a very simple model. Does anyone know what this is? I had a student who was doing an EE project, and he wanted to measure the lift of airfoils. And so what we did is we came up with the design of several airfoils. We put them on a scale. We created a wind tunnel, and what you just saw was that he measured the amount of lift based on the airfoils. And he did this with several different models. This is just one example of what a makerspace can do. How many of you have makerspaces in your school? Does anybody have a makerspace? Okay. Next question. Does anybody know the concept of a makerspace? Okay, perfect. Then you're the perfect audience. What we're going to do is we're going to keep it simple. We're going to talk about three things. We're going to talk about why you should have a makerspace, the importance of makerspaces. We're going to look at what makerspaces are. And finally, we're going to look at how to set up a makerspace. Okay, let's first look at why. There are really three reasons why. STEM is really important. Are you familiar with STEM or STEAM? Okay, it kind of came out of the United States. I make fun of the U.S. because I'm from the U.S., and the United States comes up with these amazing programs that often fail, because what they do is they have this amazingly round program, and they try to fit it in this amazingly square thing we call education, and it just doesn't work. In fact, we've had STEM in the United States for centuries. When people started doing woodworking classes, it was STEM. It was engineering, mathematics, art, science. But we just kind of changed things in education. Most of you have been in education long enough to know that it starts here, and then it kind of fades, and then 20 years later it's popular again. But we just changed the name, right? And so Makerspaces is kind of that. The second thing is 21st century learning skills. I worked on the committee that actually developed these in 2005, I think, is when we did this. And then the final thing is a holistic student. And let's look at these real quickly. And I'm not going to read these to you because they're really not, that's not what I would focus on. But application of knowledge, creativity, innovation with STEAM, with 21st century learning skills, critical thinking, creativity, collaboration. When you look at both of these, STEAM, STEM, GEMS, anybody familiar with GEMS? I think it's an Indian. Really, when you look at all of these, they all deal with the same thing. What we're trying to do is figure out what students need to succeed. And when you look at these, a lot of times our schools, the way we teach, do not address them. The biggest thing I want to address is a well-rounded student. When we look at students, we often see them as a test score, especially when you've got 1,000 students. You see the list, and you see their test scores, and you see how they do in school. But that's really not a measure of a student. So my biggest question is education a product, or is it a process? Thank you. I'm going to go back to the U.S. for a second. In the U.S., we are really good about about taking tests and quantifying students by tests. And it's become very political. And the point is this, is we've gone away from this process because in order to justify our education, we have to have a test score. We have to prove that this student actually learned something. And you and I know that just because you have the knowledge doesn't mean that you can do it. For example, I used to play baseball in the United States. I was a pitcher. I came to India. Actually, a South African taught me how to play cricket. And I know the rules. I know that when you bowl, you have to come overhand. And I know a leg before wicket. I know what a 4 is, a 6 is. I know the rules. I really know the rules. But every time I try to play cricket, people call a foul because when I pitch, I always bend my elbow. You can't bend your elbow when you play cricket. And so even though I know all the rules, even though I play a different sport, it doesn't mean that I can play the game. And in education, your students might know math. They might not know how to apply it. They may know the law of thermodynamics. They could tell you the law of thermodynamics. But when they're in making a thing, they're trying to make a perpetual motion machine, and if they understand the law of thermodynamics, they know it's impossible, but they still try to do it. Or you bounce a ball and it doesn't go any higher. Those are the laws of thermodynamics. And so we can teach the kids these concepts, but unless they put them into practice, what's the point? I'm going to make fun of American engineers for a second. I've always been a maker. American engineers, they created the minivan. The minivan was a big thing. And so I change my own oil. I take care of my car. And so I was trying to change the spark plugs. And in this automobile, the engineers made it so the only way to change the spark plugs was to take off the top of the engine. Engineering-wise, it doesn't make a lot of sense. On paper, it looks good. Everything fits. It's perfect. I save money. But they don't think beyond of what happens if. On the same car, to change the oil filter, you had to get your hand up like this, and you had to turn it on while laying on your back. It's almost impossible to do. Another great engineering feat was changing light bulbs is easy, right? In your house, if it goes out, you just unscrew it and you put it back in. Chevrolet made an automobile just recently that the only way to change the light bulb is to take off the front bumper. Not practical. And so what we see in education is that we're really educating our kids. We're teaching them these laws, and they're doing the math, and they're doing the science. But when it comes to practical application, they just don't do it. And we see it in our engineers today. They do things, and you've bought products, and you're thinking, why did they do this? And so when we look at makerspaces, what we do is we look and we say, we need to provide some practical knowledge. Get the kids in there with their hands and actually work with them. I like the idea of a well-rounded student because what we do is we teach a kid math and science, but we don't, what are they? What do they like to do? What are their hobbies? What are their interests? What are their strengths? And I think sometimes we lose that. And the greatest thing about makerspaces is we give the kids the opportunity to play. These are a couple of examples. This is a quote from a famous person, obviously, because they're quoted there, right? I make fun of people who quotes. I use quotes because that's what you want to see, right? What we have is the kids. The assignment is build the tallest tower. And so I gave them these sticks and these straws and connectors, and you can see that they're smiling, they're figuring it out. Then they create this amazing tower. He's standing on a chair, which he shouldn't be. And they're playing. And they're discovering they're working together. They're discovering things that they like to do. They're discovering things they don't like to do. And this is the best quote I know of. We don't stop playing because we grow old. We grow old because we stop playing. And I think in elementary school, we encourage kids to play. It's important. Play is a social thing. But then in middle school, we start focusing a little more on academics. And then in high school, especially if you're doing IB, IGCSE, or some of the other programs, is, no, you don't play. you have to do your work. And the irony is the kid who did, in the very beginning, who did those airfoils, the kid who did that, it was something he was interested in. And he was actually playing. It was hilarious to see. Because we would build these airfoils, and then he, oh no, we need to do this. And then he'd make this wind tunnel. He made a wind tunnel. And then he figured, and he was having a good time doing it. And he was learning, and he discovered which airfoil works best, which creates the most lift, simply by playing. And so sometimes we eliminate the play, and we really do a disservice to our kids. Okay, let's look at what a makerspace is. A makerspace is a collaborative workspace making for learning, exploring, and sharing. Okay, you can read. I'm not going to really get into detail. Here's some facts. The maker movement has been around for really going about 10 years it started, and is slowly gaining speed. I worked in a makerspace for 3 years in the United States at a science center. So I got firsthand experience, and I got to see the growth of the maker movement. And what I did is I took those ideas and I brought them to Canadian International School. Here's some Makerspace Designs. You're going to see lots of variety. This is kind of a sterile design. It's very white, it has lots of light. This is a great space to work in. They've got, in the back, they've got some computer rooms. You can see the tools and things like that. This is a makerspace I worked in. This is amazingly neat. The makers, really, I don't know why they made it neat, because it's never neat, and it shouldn't be neat. They've got sewing there. They've got electronics. They've got soldering there. Here is our makerspace. We've removed the tables. These are elementary kids, and they're making bridges. That's the whole idea, and they're collaborating, and we're trying to make some buildings and things. This is with our tables. These are just pictures. This is a makerspace. This is amazing. There's a rug in the middle. Does it look like a maker? Does it look like a workshop? It doesn't look like a workshop at all. But this is in the elementary, and obviously you don't need power tools that will cut kids' fingers off. That's not a good idea in elementary. And so what we do is we keep it simple. We have tables. We have materials in the back. A great space for working. Sorry, this is an activity that the kids were doing in that space. Okay. This is where I need to slow down a little bit. Because what we've talked about what a makerspace is and why. This is the hard part, is like, how do you make this work in your schools? And the reason I say that is because we've got a round peg and we're trying to fit it in a square hole. Most of us have curriculums in place, right? Especially in middle school and high school. And they're fairly rigid. And the time you spend, it's like, okay, I have this much time to do this concept. And if you're good, you look at the end and you figure and you plan out very well. Makerspaces do not fit in that design. They just don't. And so when we look at it, we're going to look at a couple of different ways to do this. We're going to look at educational approaches to makerspaces, and then we're going to look at facilitation. I'm fortunate I have Pavana, and she helps me a lot. It's like a marriage. Oh, it's okay, not yet. But it's a marriage. She keeps me from killing myself, like good marriages, right? She puts up with me, and it's a good thing. She has different strengths than I do. And I'm going to show you a perfect example. I work on houses, I build things, I make things work. My wife makes things pretty. And I did this activity, and Pavana did not like it. This is our art bot. Isn't it cute? Yeah, my art bot was not cute. It was a cup, but it worked really well. But everybody likes Pavana's art bot because it's cute. And so when you look at facilities, when you look at who to put in there, you need people of different strengths. The makerspace that we had in the United States, we had a graphic designer, we had an art major, me, and together we worked really well. Oops, I'm doing some tag. Because it's making noise, isn't it? They're like yelling at me over here. No, it's good. Okay, let's get to this. Sorry, I get distracted very easily. I don't have my glasses on, so I can't see what I'm trying to read. Let's look at educational focus. There are two things that we do. In a makerspace, we have high-tech, we have low-tech, and we have no-tech. High-tech, for example, 3D printing. So these are some examples of 3D printing. You get on a computer, you design it, you print it out. High-tech Arduinos. This is a sensor that we used for a bird. We made a birdhouse, and we made this sensor that when the water runs out, it makes this really annoying beep, which we discovered scares the birds away. It wasn't really a good idea, but that's high-tech stuff. Low-tech would be circuits, soldering irons, things like glue guns. And no-tech would be where the only thing that happens, there's no such thing as electricity involved. I've only seen one makerspace that did this. It was a woodworking shop, and the tools were the drills were hand drills. Hammers, you could not use any screws. Everything had to be used with dowels, and it came down to the very basics of like how we used to build stuff. I can't imagine a no-tech space. Our space really is high-tech. We have some high-tech things, but we have a lot of low-tech things. I prefer using a hammer, hammers, nails, knives, cut things out, doing things like this with soda bottles. The kids get to use their hands. It's easy. They create their own designs. There's lots of different things. Pavana is more of a high-tech person, and this is great. I know how to program, but when I learned programming, it was 1982, and it was Fortran, and they don't even use that language anymore. And I don't like programming. She sits down and she works with the Arduinos, she works with the Raspberry Pis, and she does the programming for us. The other way is what we call formal and informal. For example, this would be a formal setting where the teacher comes up and sets a session and talks to the students and has them do something. It's like a formal approach to learning. Informal is where if I had activities on each table, you kind of come in and you do this for a while. Oh, I don't like that. You do this. More of a Montessori approach. Is familiar with Montessori approaches? Yeah, where the kids just kind of come and they explore, okay? Both of those work really well. When I worked in the Science Center, I would have classes, and I would bring in a class, and I would say, okay, we're going to do 3D printing, and I would go through the steps of 3D printing. I would teach them how to do 3D printing. They'd do a design, and then they would print it. It was a more formal approach. The one I enjoyed the most is where I set up centers, and kids would come, do something, and if they got bored, they would just leave. And the informal thing is kind of cool because it drives teachers nuts because you don't have the control. I mean, really, all you're doing is you're watching. But for kids, it's refreshing. It's like, oh, this is cool. And I've got a kid named Charlie who is an amazingly bad student, but he does really well in the makerspace. We give him ideas, and he does designs, and he latches onto something, and it's just amazing to see him in an informal setting. He doesn't do well in a formal setting. He does amazingly well in an informal setting. This is how I set up my makerspace. Good, I got time. There's two ways I set up a makerspace. One is I'll set up a challenge. So, for example, I'm going to move forward. I hate being on stage. What I would do is at this table, I would say, okay, your job is to build a tall tower, okay? And so then you have to get together, and that's the challenge. Or you have to build a robot, or you have to design a building that has a certain number of windows and something like that. And then the kids sit and design. It's problem-based. It's great. It's a great activity, especially when you have, like I say, you have to build the tallest tower, you have to build the tallest tower. And then suddenly there's this amazing competition, and it kind of spurs. I like the challenge base. It's easy. I set up the centers. It's very easy to do. The other one is exploration-based. And exploration-based is where you put a bunch of Legos on the table, or you put little bits. We use a lot of little bits. And you put the little bits on the table, and they're just there. And the kids come in and play and build things and experiment. Both are valid. We use both of them in our space very well. The challenge base is easier for teachers, for us to set up. So what we do is each week we have a different challenge. This week they were building a city. The week before they were doing periscopes. Next month we're doing buoyancy challenges. And so what we do is we set them up, we put them on the table. The kids come in, they have to read the instructions. We do some facilitating, obviously, and then they do the challenge. It's a great way to do it. I'll show you some pictures. This is an example of a robot challenge. And so you see the table. We have materials on the table. We give the instructions. The kids come in, and they read the instructions, and then they do the challenge. Great, very simple. I like this because I've got 100 different challenges. So if a teacher comes to me and says, we want to do something with boats. And so then I'll come up with a boat where they have to build a boat that floats, but they have to build it out of clay, which doesn't float. And so stuff like that. I'm getting a little hot there. Let's see. This is an exploration base. These are mini bits. What I did is I set them on the table, and students come in and they just play. Now you can see their instruction books, and you see the two girls here. They're not looking at the instructions. They're just putting things together. You look at the kid on the other side, he's got the rules out, and he wants to make sure that he's following those rules. Some of us really like following rules. Some of us don't. And so it's the exact same. The kits are really the same. It's just they're doing them differently. So this is a great example of exploration. Organizing your space. You saw some spaces earlier. Really, the way we organize a space is, so what do I have? Okay? Do I have a room? Do I have electricity? Do I have ventilation? What does it look like? Who are the experts? I'm kind of an expert. When you started, you really weren't an expert, but you had skills that we need. You don't need to hire an engineer to be in the makerspace. In the U.S., sorry, I pick on the U.S. a lot, which is okay. I'm in India, right? In the U.S., they make the librarians do it. They do. Seriously. They have nothing else to do. And so they find, okay, librarian, you can do this. Librarians get dumped. Any librarians here? Librarians get dumped on a lot. The media, everything they have to do. And so in the United States, they pick librarians, and they're not enthused about it. The person you want in your space is a person who wants to be there. Seriously. Artist, math person, it doesn't matter. I have my bachelor's is in speech and theater. But I enjoy working with my hands, and I said, I want to do this, and so we just did it. Okay, there are 3 ways to do this. If you don't have a space, I'm going to show you 3 different ways to do this. One is a classroom. Let me make sure. Let me go back. We have a designated space, a classroom. It's designated for Makerspace. We bring people to the space. If you don't have a space and you have things like these kits, then what you can do is you can have the teacher come in and check out the materials. And then suddenly their classroom becomes that space. It's a little bit limiting because you might not have sinks and things, but that's, I have Angelina, one of our elementary teachers, who's amazing. She's always stealing, signing out stuff from my space. And it's great because she knows the value of it, okay? That's another way, if you don't have a space, to do this. You don't need tons of materials. Seriously, if you have Which do you think I use more, a glue gun or a 3D printer? A glue gun. We use glue guns all the time, okay? We bring recyclable materials in there. Seriously, you don't have to have a lot of stuff. You can take trash and make it in fact, most of this is recycled stuff that we use. And this is another thing, outside venues. Has anybody been to the Fab Lab in Bangalore? It's a makerspace. Okay, there are several makerspaces in Bangalore. And if you want to take your kids to there, you say, this is what we want to do. They will come up with a challenge. You take your kids there. They have all the equipment. They do an excellent job. We've taken kids there. We've taken 8th graders there, like 30 kids, divided them up. They created these birdhouses that monitored the water. And it's amazing what we figured out what didn't work. But we went to those spaces, and it worked out really well. Even though we have a makerspace, we actually brought in a group to the school that makes bikes. And so they had these challenges. They had to build a bike from scratch. Took the bike apart. They had to use the tools, put it together. It was an amazing activity. And we brought those people into the school. So there are lots of ways to do the maker spaces. It's not just a room. You don't have to have 3D printers. You don't have to have computers. You don't have to have all this amazing, and I call it shiny stuff. We buy stuff because it's shiny, because it's new. 3D printer, whoa. There's no reason to have a 3D printer until you have computers, because it's not about the printing, it's about the design. And so when you think about maker spaces, you don't have to have all of this neat stuff. Okay, I kind of talked about this. I'm going to move forward because I want to show you some of the things that we do. Pavana, can you come up and give me a hand? These are what we're going to do. Is we're going to show you some ideas, some things that we do, and we're going to. Good. I'm going to show you something. A problem that a student did. Just pick up something and then we'll talk about it. I'm going to talk about this first. So we're going to see. We're running. We got about 3 minutes. I had a student, Charlie, and he wanted to build a thing, a container for a car. And he wanted the car to drive up and have a display, okay? And so then we came up with this, he came up with a design. And so this is the design. To do this in a 3-dimension, it takes a little bit longer. So what he had to do is he designed it like this. And then I said, okay, it won't print that way. You have to change the way you print it. What you have to do is you have to take the box and you have to print it upside down because you can't print in midair, right? I mean, the printer, it's like you can't draw and it just doesn't work. So I gave him this problem. I said, okay. I said, how big is the car? Well, I don't know. What's the scale? Well, it's this long. Well, is it a 1:18 scale? Is it a 1:20 scale? So he had to figure out how big it was. Then he got on and he measured it and he came up with an idea. And so he did this. He printed it. And he printed it like this, and he had to make a way. He had to design this so it would slip in, and then the car was this big, and then it went. You get the idea. It failed, right? It failed. So Charlie is probably learning more from this failure because he missed when he was looking at it. He mismeasured when he was doing the design, and he went, oh. Or some of my kids work in millimeters. They work in centimeters. The program works in millimeters. Yeah, it's amazingly small stuff comes out when they're done. And so this is a great example of a kid struggling to try and do something that he really wanted. Okay. Pavana, what do you got there? Pick up something. Cool. These are Lego kits, physics kits. We have a lot of them. It works 2 ways. Go ahead, just turn it on, see what happens. Maybe it'll work, maybe it won't. Got it. So kids made this. It's actually, you can make it so there's a generator with it so that you put it in the wind and it'll actually generate electricity. These are kits that we have. This is another kit. These are real popular. This is, okay, these are nice. They're way too expensive. I don't buy new stuff. What I find is a lot of these things that are for sale, you get them used, they're extremely cheap. These are called Little Bits. It teaches, they're magnets. It teaches the kids how to do circuits. Very simple. Like an 8-year-old can do this. We get kids operating in this. We've got the clock that we've made. We have a boat challenge where the kids have to, the thing is they have to create a boat that will create the most force. And they can do it this way, they can do propellers, kind of a fun thing. So my point is this, Makerspaces, great opportunity to get kids working. You can make them work in your house, or you can make them work in your school, you can go outside of school. But overall, they're an amazing way to get kids to have fun with education. That's what we're all about. Thank you very much.